This is an electromagnetic crane used to sort metal in scrapyards. This is a smaller, simpler version that I built using cardboard and other materials, used for picking up safety pins. You may have seen these and wondered, how does a magnet turn on and off? Well, these aren't ordinary magnets, like the ones in your kitchen fridge. These are electromagnets, and they work a bit differently. Let's take a closer look. This is an iron screw, and the shiny stuff wrapped around it is a special kind of wire called magnet wire, which is just copper wire with an enameled coating rather than a plastic coating, so it's actually more efficient for this purpose. This wrapped screw will become a magnet when we introduce it to an electric current. But how does an electric current magnetize an iron screw? I don't know if you've ever held a compass up to an electronic device, but if you have, you might be familiar with a relationship that was first discovered by a Dane named Hans Christian Ørsted. One night in 1820, he held a compass near a live current, and noticed that the compass needle, which normally points towards Earth's magnetic north pole, changed direction, the same way that it would have if you were to introduce it to a magnet. This proves that electricity and magnetism were two forces connected, and thus the study of electromagnetism was born. An electric force influences a magnetic force, and a magnetic force influences an electric force. This is sort of what they were talking about in Stranger Things when all the magnets stopped working. If you've ever studied magnets before, you may know that iron and steel are two types of metal that are attracted to magnets. The difference is that steel is actually just iron with some other stuff added to it to keep it from rusting. However, this also causes it to retain a magnetic charge when you introduce it to a magnetic force. Since we want our electromagnet to turn off when we interrupt the current, it's important to use an iron core. When the current is going, it creates an electromagnetic field, which attracts the safety pins, or scrap metal. Now, what if I told you that Ørsted's twins were actually triplets? Looking at you, Mr. Forkel. In the 60s, the 1860s it is, a Scottish scientist by the name of James Clerk Maxwell was very interested in electromagnetism and created a series of formulas known as Maxwell's equations to represent the relationship between electricity and magnetism. Not only that, but he also theorized that electromagnetic waves travel at the speed of light, and that light exists in the same medium as electric and magnetic phenomena. He described light as a propagating wave of electric and magnetic fields. He called it electromagnetic radiation. Later, in 1888, a German physicist, Heinrich Hertz, proved that Maxwell's theories were correct. His experiments showed that light and heat are electromagnetic radiations. Hertz demonstrated that the properties of long wavelength electromagnetic waves were consistent with those of shorter wavelength visible light. So basically, light can turn metal into magnets. Maybe electromagnets are the key to flying cars. Or maybe their best purpose is served in scrapyards. Either way, I think they're pretty cool. Thanks for watching.